Okay, for number 10, right? And we're kind of running along these problems over here. And, one thing nice about factorization is um, sometimes you're going to get stuck. And you won't know what to do, by the way. Now, kind of looking at this, if you were to use the AC rule, it's the 10th problem, by the way, I could write that down. 9 times 9 is 81. And what I immediately notice is that there are two numbers that multiply to 81. Certainly anything in large number of numbers, right? I could actually an infinite variety. But I'm going to say simple cases, not too many simple cases. And I'm going to say, maybe there's two numbers that when added together would give you the middle number, which is 10. But as I look at that, I start to realize I don't think I could figure that out. Like 9 and 9, 9 and 9. That's not working out. All right, I'll cross that one off. What else could you try? You could try 3 and 27. There's not much choice, by the way. And I hope you start to realize that 3 plus 27 is not going to work. I'm kind of exhausted in this over here. So at this level of the game, what we'd recommend you do is say it can't be factored over the integers. So what I'm going to do is I'm going to erase this over here, my work, and I'm going to write that down now. I'm going to say can't be factored over the integers. I tried. We just tried those integers, right? Now someone says, I wonder if it could be factored over other numbers. And what I recommend over here is that there's many ways of doing it. What I'm gonna recommend though is to look for the roots of the problem, the roots. Like if I know what a root is, I know what a factor is. For example, if one of the roots was a, the factor would be x minus a. If one of the roots was the letter b, the factor, would be x minus b, so forth and so on. All right. Now I don't know what they are, but I'm just saying if I knew the root, I would know the factor. Now the problem with come up with the roots, depending what level of the game you're at, finding those roots could be quite difficult, right? But there's all kinds of ways of doing it. So one thing I'll do is I want to write down one way of doing it is by using the quadratic formula. And the quadratic formula, let me write this over here, 9, sorry about that. I'll get my pen back. 9x squared plus 10x plus 9 equals 0. By the way, for a lot of students, this is a great answer over here. Can't be factored over the integers. All right, I'm going to use quadratic formula to figure out the roots, though. Maybe they're not so bad, by the way. Maybe they're terrible, though. Let's take a look at it. What do you get? X equals. Now, if you don't have the quadratic formula, you'll have to wait till you see that. That's certainly covered in most basic algebra classes. What goes on bottom? Twice the coefficient on the square term, so that's going to be 18. Then what do? You take the opposite of the coefficient on the linear term, that's minus 10, plus or minus, it's getting nightmarish, isn't it? The square root. Well, the coefficient on the linear term squared, which is 100, minus 4 times the coefficient on the square term, which is 9, times the constant term, which is 9. All right, looks pretty nasty, doesn't it? Let's write this down. X equals, and again, if you haven't seen the quadratic formula yet, you probably should be skipping what I'm doing over here. This is minus 10, plus or minus. Well, I got to what's on the inside. What I'm going over there, it's, 81 times 4, so 324. Again, 9 times 9 is 81. 4 times 80 is 320. 4 times 1 is 4, so 324 minus 100. What does that give you? 224. Now, granted, when I say that, I'm looking at the computation over here. It's not 224. It's minus 224. Right, what about that complex number? And yeah, this is nasty. There was no way I would be able to look at those numbers and get this out of it. That's going to be I. Now, before I say anything, 224, I'm going to start factoring that. 2 goes into that 112 times. 2 goes into that, let's see, 56 times. Let's see if I did that right. 224. All right, 2 goes into 56. Let's see, 25. And then 3, 28. and 2 goes into 28 14 times, and then I'm left with 2 and a 7. And someone says, why'd you go through that? I'm starting to realize there's perfect squares in it. They're all over the place, all right? So what do you get? Well, that's going to be 2 times 2 is 4 times 2 is 8 times 2 is 16. So the square root of 16 is 4. So I'm going to say 4i. And then what do you get over there? Something I couldn't do, which is 2 times 7, which is 14. That's the root of 14. And that's all over 18. Granted, I know it's a nasty number. And again, if this is scaring you, or if you've not seen the quadratic formula, you would be avoiding this. Let's keep doing it. And I'm going to divide top and bottom by the number 2. What do you get? Minus 5 plus or minus 2i root 14. I'm dividing by 2, by the way. And that's going to give you 9. All right? I know the roots. There's 2 of them. These are 2 roots. The roots are as follows. X equals, let me write it down for you. So minus 5, we'll clean it up later, by the way, plus 2i root 14 over 9. And the other root is going to be minus 5 minus 2i root 14 over 9. And it gets more complicated. I realize that. I'm going to write a factorization down. It's going to be x minus those roots. I'll write that down. So minus 5 plus or minus, not plus or minus, I'm sorry. That would complicate matters even more for me. Minus 5 plus 2i root 14 over 9. And what goes over here? Let's take a look. X minus 5 minus 2i root 14 over 9. All right? And I'm going to say that's a factorization of the problem. Unfortunately, it doesn't have the correct coefficient. All right? Someone says, I wonder what the correct coefficient is. It's 9. We're not even close. All right? But let's go through this. Again, if this is scaring you, move on to another question. And what are you doing over here? This is your answer over here. I couldn't factor it using integer numbers. No kidding. No one can. But we can factor it using complex numbers. What I'm going to do, though, is I'm going to multiply this by 81. And someone says, why would you do that? Well, I associated 9 with the first guy. Don't worry, we'll get the factorization. And I'm going to associate the 9 with the second factor. It's tough, though. There's no doubt about it. So what do you get over here? You're going to get 9x. And let's see what you get over here. This is the second term, by the way. The 9 is going to cancel off. And what do you get? Minus a minus 5, which is plus 5. And then minus 2i root 14. Let's do the second guy. What are you going to get? 9x. And the 9 is going to cancel the denominator, second term. We left off with minus a minus 5, which is plus 5. And then minus a minus 2i, which is plus 2i root 14. Yeah, it's nightmarish, isn't it? I could not have done this in any other way, though, except by using the quadratic formula at this point. Okay, I'm looking at this over here, and the coefficient is now too big. It's 81, so I got to multiply it by 1/9. I'm going to put a box this over here, indicating this is the factorization of that problem. Now, by the way, when I went into the problem set, one of the provisions was that some of these things, you couldn't factor it using the integers. All right, and this just happened. I couldn't do it. I could not factor using my finger numbers, by the way. It wasn't happening. But anyway, what do we do? Quadratic formula, found the roots, and now we found a factorization. Am I going to check this? No, I'm not going to check it. But we're done. Thank you.